Hey guys, today we're doing Module 18, Lesson 2, Identify and Draw Lines of Symmetry. Today we're going to be able to identify two-dimensional figures that have line symmetry. I can draw all lines of symmetry on a two-dimensional figure. Okay, so it says, a computer club is designing new signs to have printed and displayed outside. The two-dimensional figures used for the signs need to be symmetrical. Trace, cut out, and fold the figures below in different ways to test for line symmetry. So we're testing for line symmetry, and this whole trace, cut out, and fold, this is optional. You should be able to look at the pictures at the bottom and then be able to draw a line through them. So identify the figures that have line symmetry. Draw any lines of symmetry on the figure below. So in the first figure we have an arrow. It looks very similar, but if you look at this line right here, this line is shorter than that line, so they're not symmetrical. I cannot draw a line, so you would think you could typically draw a line here. It does not become symmetrical, so that one does not have a line symmetry. All right, in the next one we have a rhombus, and the rhombus we can cut it horizontally across. That's one line of symmetry. We can cut it vertically. We can also cut this line diagonally and diagonally. So this one has 4 lines of symmetry. The next one looks like, I don't know what it looks like, a crown. So this one, if we cut it this way and fold it, my lines are not perfect, I apologize. If we go straight down and fold it, we would have a line of symmetry. The next picture, the fourth picture, this one right here, does not have a line of symmetry. That looks like a little text bubble. The picture next door, it's got, it's a quadrilateral, it's not a regular polygon, so it does not have any lines of symmetry. And then the last one is an equilateral triangle. Equilateral triangle, we can draw at each point. So from this point to the middle, that's one line of symmetry. I turn my head, this line right here to the middle is a line of symmetry, this line here is a line of symmetry. So we have 3 lines of symmetry. So from point to the half, from point to the half, point to the half. So those are our lines of symmetry. On the next page, it says the polygons below are choices for the new signs. Which of the polygons are regular polygons? So regular polygons means they have lines of symmetry. It's our traditional shapes. So we look at isosceles. Isosceles triangle is not a regular polygon, but a square is. So we'll write square. Okay, the next shape, a trapezoid, is not a regular polygon. A regular polygon, all your side lengths are the same. So for a triangle, it would have to be an equilateral triangle, a square, a 5-sided shape. A hexagon would have to have all the same sides. We don't have any hexagons. A regular octagon, and it says regular right here. So we're looking for regular polygons. So we'll go with the regular octagon. An octagon is an 8-sided shape. Octagon is an 8-sided shape, and what it means is all 8 sides are the same length. So that length, these are all the same length. They have equal lengths. So that's what it means by a regular polygon. Same or equal sides, same or equal sides. All right, and then the equilateral triangle, so this is our 3-sided shape that would be equal. So we'll say, oh, I'm running out of room. So we have 3 of them are equilateral. I write too big for the space they give me. They always give us just a little line. So the 3 shapes that would be regular polygons would be the square, the rectangular octagon, that's OCTAGON, and the equilateral triangle. So let's look at the shapes below. I'll clean these up. And they want to know Identify the number of sides for the polygon, so we can count the sides, and then they want us to draw all the lines of symmetry and identify the number of lines of symmetry. So the first one, we have 3 sides, it's a triangle. And then do we have any lines of symmetry? If we draw one line straight through the middle, we have 1 line of symmetry. All right, a square has 4 sides. How many lines of symmetry? We can draw it horizontally, vertically, and 2 diagonal. So it has 4 lines of symmetry. Trapezoid, it's a quadrilateral. It has 4 sides. How many lines of symmetry? We can cut it in half vertically, so it has 1 line of symmetry. The octagon. Octo means 8, has 8 sides, and this is going to be tough. So we got to do half to half. So we're going to use these blue lines to guide us. An octagon actually has 8 lines of symmetry. So 1, 2, 3, 4, and then we can draw at the points. Oh, this is so hard. 5, 6, 7, 8. Oh, it's so messy. But an octagon has 8 lines of symmetry, side to side and then points to points. 8 lines of symmetry. Hope y'all do better with your pencils. Equilateral triangle has 3 sides because it's a triangle. How many lines of symmetry? So a triangle we draw from point to half. So from this point to half, this point to half. So it has 3 lines of symmetry. And this is what we should have looked at up here. A regular polygon has all sides equal in length and all angles equal in measure. So I left out the angle measurement. So all sides are the same length and all their angles measure the same. On the next page, been dreading this one because I can't draw. We're going to do a little connect the dots. All right, so we have this beautiful pattern right here. So think of like this one shape in the middle. It says Nathan's art studio is painting clay tiles to use in a walkway. Nathan starts a design that will have 2 lines of symmetry, and you can see right here, we got a horizontal line of symmetry right here and a vertical line of symmetry. So they've given us our lines of symmetry, 2 lines of symmetry. I'm going to erase that. But they've given us, you see the dotted blue line, there's our 2 lines of symmetry. And I'm going to, I guess I'll draw it in blue. No, let's draw it in red so it pops out. All right, so we have got to connect the dots basically, and we want to draw what's over here in this quadrant right here and the other quadrants, okay? So we have to count over, and this is always hard for me. This lesson's so hard for me. Those of you that are good at art, you'll like this one. So we're going to count over 2. So 1, 2, and then I've got to count down 1, 2, 3, 4, 5, 6, and they go diagonally down. So 1, 2, 3, 4, 5, 6. It's hard to write on the board. I wish I had a ruler. Like that. And then we come over here, so 1, 2, 3, 1, 2, 3. I'm gonna connect here. Some of y'all might already be finished. And here we got 1, 2, 3, 4. So we go up 3. So we connect right there. Is that right so far? It's close. All right, so we have 1 line here. I'm gonna draw another line here. So we've got connect right here. And then I think we're gonna draw the same shape again. Oh, this is so hard. So let's look opposites. It's a mirror image. So 1, 2, 3, 4. So do that line there, this line here. All right, then we've got a diagonal, so we gotta go down. So from here, it's 1, 2, 3 more dots. 1, 2, 3. I think. Am I doing it right? I think so. So 1, 2, 3. This is the inside. So we got to do the outside part. So let's do the outside. It goes 1, 2, 3, 4, 5, 6. So, oh, which way? Did I do it right? I don't think I did it right. Guys, if you're copying me, I'm so sorry. These lines are not right. I told you this is a hard lesson for me. Guys, if you're able to do this, congratulations to you. let's try the 1, 2, 3, 4. 1, 2, 3. So these go connected. Yes, that looks much better. Alright, so we've got 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So draw. Is that right? If you're at home and you're laughing at me, congratulations. Okay, so that line right there, this line. Alright, let's try again. Connect the dots. Okay, so it goes all the way down diagonally. Oh, it's not perfect. And then connect there. Oh. Anybody get theirs to look like mine? That was challenging. So if you mess it up, use your eraser, clean it up, do your best. That was tough for me. Not good at art. Okay, let's look at the bottom. So that should just maybe, hopefully it was fun for you. It was not fun for me. At the bottom of the page, let's look at number 1, 2, and 3. Do these on your own and then check yourself. So number 1, Rocco draws a regular polygon, meaning all the sides and all the angles are the same, with 12 sides. Regular polygon, it's got 12 sides. Next, he draws all the lines of symmetry. How many lines of symmetry does he draw? We know in a regular polygon, how many sides is the same as how many lines of symmetry. So how many lines of symmetry does he draw? How do you know? He should draw 12 lines. 12 lines of symmetry. He will draw 12 lines of symmetry because drawing a regular polygon has the same number of sides equals the same number of lines of symmetry. Because number of sides, which they gave us was 12, equals to number of lines of symmetry. We'll also have 12 angles in it. Did I spell that right? S-Y-M-M-E-T-R-Y. Yes. Alright, draw the lines of symmetry. So in picture 1, we only have 1 line of symmetry. In picture 3, we have 4 lines of symmetry. So we have the points, diagonal, diagonal. 4 lines of symmetry. That's it.